All right, so we're going to get started. Welcome to teaching statistics across any setting. So I'm glad we have a small group here tonight, but if for some reason you want to go watch I think it's an NCAA playoff game or something like that, if that's going on and you'd rather watch that, feel free to leave and catch the recording once it's posted on our YouTube channel. We have two people presenting tonight. They're doing a slightly longer version of their best practice presentation from the AP Statistics reading. We have Keisha Brown with us tonight, and we also have Tom Rothery with us tonight. Keisha is going to be talking about StatCrunch to the rescue, and Keisha is an assistant professor of mathematics at Perimeter College at Georgia State University. Her educational background includes a bachelor's degree in computer science from Georgia Institute of Technology, a master's degree in mathematics education from Georgia State University, and a master's degree in applied statistics from Kennesaw State University. Her passion is to help people achieve their goals in life by assisting them through learning and mastering mathematics. Keisha loves demonstrating the power of statistics and how it can be utilized in every field of study. She also enjoys learning about various technology that she can implement within the classroom and sharing this knowledge with her peers. And I know I'm very excited to hear about StatCrunch and how I could possibly use it for a minimum of demonstration purposes, but more specifically to have my students be able to use it as well. So I'm going to turn the presentation over to Keisha.
All right. Hi, everyone. Are you able to see my screen?
Yes, we can.
Wonderful. So I am Keisha Brown, and I'm glad I'm able to share with you today one of the softwares that I absolutely love, and I don't get paid by Pearson. This is actually a genuine love for the product. It is Pearson's web-based statistical analysis software. So why do I think it is worth it? A lot of students are visual learners. And so this software makes it very easy for them to visualize the concepts that we're talking about, and it makes it very easy for them to make slight changes to see the differences. Gase says that we should use real world data, and we are limited by the graphing calculator in how much data we can have, how long it's going to take for students to enter it, and what kind of visualizations they can make with it. Learning this kind of tool makes it easier to pick up other tools that they might use in the future, other point and click types analysis tools, Minitab, Jump, SPSS, and it gives students a greater ability to analyze and synthesize their data as well. So number 10, I first heard about COVID and the how important it was about to be in March. And so I went to the New York Times website and I found this map that listed the number of cases. So I found the data set, and you can see this is a long time ago. And these are the total number of cases by state. So I brought it into class and I said, hey, let's look at this. So in StatCrunch, we have graph, map, US locations, our state labels, and our values. And we can put our access title on there. I'll skip that step just for brevity's sake. And we were able to create the same exact map that we saw on a national publication. And so students were excited that they said, wow, I thought it would be a lot more difficult to create something like that. My number 9 reason, time series graphs. Here we can see how long Bitcoin has been around and the current price per Bitcoin. So I have selected some dates, and then if you're in class, you can actually provide a review at the same time as well. So you can talk about, well, if I don't want to use all of these dates, let's use some sampling techniques in order to select some of these dates. But we can create this graph, a very similar one, by going under graph and index and time plots. Then our price in dollars, and we can change the label to the date. So here, once again, I skipped over creating the access titles and the title just for time, but we can see a graph that's very similar. I also like to use this and talk about how does changing the vertical axis affect your graph? and they can compare side by side and see what these graphs look like if you don't start that y-axis at 0. Number 8 and 7 reason are my pie charts and bar charts. I love when we start talking about probability to talk about the Georgia lottery and how the lottery games work. And in our state, a lot of students are surprised to learn in class that part of the revenue goes to actually supporting education. So it goes to the Hope Scholarship for students to go off to college. It goes to funding pre-K for students. It also goes to building projects as well. So I found on Georgia's budget for 2019 where the state revenue comes from. And so a large amount of it actually comes from those lottery funds. We can create a pie chart with this information. And I forgot to put my label on there. But what I like about this feature is even if students forget how to actually create a graph, it's very easy for them to say, oh, that's not quite what I wanted to do. So let me change that. So my categories are state revenue source, my counts are in amount in billions, and then they're able to create that pie chart very quickly. We can also change this over and create a bar chart as well. And it was very interesting to me, the colors that they chose to create this pie chart. But I noticed here under color scheme, they also have a colorblind safe mode with only 6 colors. And so that may not be a great color for people who are colorblind, but it allows you to have different shades. And then the pie chart, it does change the shades as well. My number 6 reason, frequency distributions and contingency tables. So I have the 2019 SAT scores in Georgia by district, and I have the English and the math means bend, and I'll show you in my number 2 tip of why I love it, how to do that binning. But we can create a frequency distribution for these values. So under our stat features and table and frequency, we can select more than one variable at a time. And then we can quickly create a frequency table to see where do the majority of students fall with their means. We can talk about why do we think that the majority of students on the English test score between 500 and 550, and why do we think for math it's between 450 and 500. So we can get more interaction from students, and even if they're guessing at reasons, it gets them to think outside of the box about these particular values, and it doesn't take much time to actually create these. We can also create a contingency table for this data as well. And I always forget this one. Let's see what we can do. There we go. So we have our contingency. There we go. So our row labels are in bin for English. Our column labels are in bin for math. We can have row percentages or column percentages created for us. We can do hypothesis testing as well if we want it. And then we have a contingency table with our English versus our math scores as well. So we just created a support class for our elementary statistics course, and we tried to identify what are these prerequisite topics that students are missing. So we use this for our conditional probability, but we never actually taught them how are these contingency tables created. So this allows us to put data into their hands to see, okay, this is how we actually create these tables that we're using in order to calculate these probabilities. Reason number 5, correlation by eye is typically a game that we do in class to make sure if they're understanding the concept. So we can randomly generate some scatter points, and then we can have the students in class guess what they think the R value is here. Then we can type in a number, let's say 0.7. I think it's positive. Ooh, no, that says it's negative. So we can talk about, why do you think it was positive? Why do you think they're saying it's negative? We can also talk about outliers. So how does changing just one value, how does that make such a big difference in terms of that R value? So very easy for students to see, and we can easily talk about these concepts. Number 4, creating my own surveys. With StatCrunch, you can create your own survey, and they save all of these results for you. And so at the beginning of the semester, I used to give my students on the first day this data set because I was in a computer lab. So they will answer all of these questions. And at the very end, they're able to see everyone's responses. And so it automatically creates all of these basic graphs based on those. And then during the semester, we use this data to actually answer questions. So we can talk about favorite color, and we can talk about response bias. So what if I change this to a closed or open question? How do you think these answer choices will differ? Number 3 and number 2, simulating distributions and binning values. So after a test, what I like to do is get the entire data set from all of my students and give them the data. And I ask them, what was the highest score? What's the lowest score? What's the shape of the distribution for this test? And since I don't have any data just yet, I can simulate a distribution. And my test scores are never normal, but we're going to use that for this particular example. So let's say we want a normal distribution. I want 100 rows, 1 column, a mean of 78. That would be a dream. Standard deviation of 5. And now I have 100 different student test scores that we have. And I would give the students this data and I would say, okay, now I want to know how many students scored A's or B's or C's or D's or F's. And if students tried to do this by hand, they would quickly see that that is crazy. So we need some better techniques. So what we can do under data and bin, I want to use the normal column, and we can let the software create these bins for us, or we can use cut points. So since we have a grading scale, we defined our cut points as 59.45, 69.45, 79.45, 89.45. So one of the little bitty things that I don't like is that the upper class limit and the lower class limit, they don't modify those values. So it takes a while to reiterate to the students, okay, you need to make sure that you're paying attention to these values. This is not the upper limit here. It's a little bit slightly below that value. So now we have everything in bins, our classes, and we can create that frequency distribution. So now we can talk about, oh, there were no A's. Then you have 35 B's, 63 C's, and 2 D's there, based upon the type of distribution that we have. Last but not least, number 1, my absolute favorite thing that I love are the calculators. So pretty much in my class, after the probability chapter, it all goes downhill from there. There is something about sampling distributions and the normal distribution and hypothesis testing that students don't make that connection. So this helps them a little bit with making those connections. So we're able to have our different distributions here, and we can enter in the parameters that we want. We can change our inequality symbol. And what I really love about the binomial one is you can clearly see what we're calculating the probability of here. So a lot of times the expectation is, oh, students should already know these key terms. of at most and at least, but it doesn't always click. It takes a while. So at least here they're able to see, okay, this is the only thing that I'm finding a probability of. I also love on the normal calculator that you can type in the random variable, but you can also type in the probability that you want as well. And so rather than the students have to decipher and figure out between, okay, do I use normal CDF here? Do I use inverse norm? Here they can just use this one tool in order to calculate everything for them. Those are my top 10 favorites for StatCrunch. Thank you for allowing me to share this evening.
All right, thank you very much. I was having trouble getting my microphone back on there. Thank you very much, Keisha. I didn't see any questions pop up in the chat, but I was playing around with it myself a little bit while you were doing things, and I was just trying to do like a chi-square situation, and I tried one of the applets. So I think it was one of the applets. They have games, and there was one for fair dice. So I was trying that, and I rolled the dice from Lucky Town Lucky Town Dice Company, and it gave me 100 die rolls. And the question was, are the dice fair? And I was trying to do a chi-square with it, but it wasn't like putting all the ones together and counting all the ones and all the rolls of 2 and things like that. So, how might I do something like that? Like, I think that was where you were kind of like binning things together. Is that how I'd want to do something like that?
Well, it would depend. I actually have never used that particular feature. So in our course, we actually removed the topic of chi-square from our course. And so I pretty much focus on all the basics.
Okay, well, let me share my screen here for this, and maybe we can figure it out. I'm just curious as to how easy this is to use. So I think you can see the applet there. So I did this. I said there's this fair dice. I said it says a game. Is it fair dice? Determine if a company's dice are fair. So let's do high rollers. That sounds interesting. Or maybe dice baby. That sounds really good. And so I said compute, and I just did 100 rolls. All right, I don't know about that. That doesn't look very. I mean, at that point, I'd turn it over to the students and say, "What do you think?" In terms of this die being a fair die. And then I was wondering, analyze the rolls. It says the data was stored into a column. So, over the column is here. So then I was wondering, like, do they have the chi-square? There's a goodness of fit. And I said, let's do dice baby roll expected. And I don't have the expected. So like, that's the one thing.
So what's the?
So I originally clicked on all cells in equal proportion, but when I do that, it doesn't really like it. See what it's doing here? It's saying I have 99 degrees of freedom, and it's, I don't want it that way. I want things to be grouped. So I was just trying to figure out.
So I would create a frequency. So go under stat and tables.
Stat and tables.
Tables.
Frequency.
And frequency.
Okay. On the dice baby roll.
Yes.
Okay.
And then scroll down. I can't remember if there's an option to save that. Yes, at the bottom, the output, store data in. Perfect.
All right. Well, that looks good. So maybe now I'd want to do on how would I want to do this now? Any suggestions from anybody out there? That would be good too.
This is my first presentation I've seen on StatCrunch. So
yeah. So obviously, if we had, I almost feel like I need another column here, like, because if I'm going to have an equal frequency, so this would be like my expected here. We'd have 100 divided by 6 because there was 100 rolls, right?
And there's another thing about StatCrunch. You cannot do inline calculations. So you would have to find the actual decimal value and type that in.
Okay, so 100 divided by 6. So yeah, 16 2/3. So we'll just say 16.67. So I'm just kind of curious as to how easy it is to do some of these things. That's all. And how intuitive it is. So you don't have to have any, you don't have to pay for this, right? It's free.
No, that's not true. But
right.
there
No,
is a minimum cost.
Okay.
So I think it's only if you're not using the software for anything else, you just want access to StatCrunch. I think it's like $10 or $15 a semester.
Per student then?
Yes.
Okay. All right.
But with ours, our student uses their textbook and the software and in order to do their homework and their quizzes. So it's all together.
Okay. You can see that I've logged in here with my username. So at some point I must have created some kind of account with StatCrunch, and Pearson let me have a free access to this at some point in time, I guess, for demonstration purposes. So, I mean, I might, or even to create some of those nice graphs, that might be nice as well, to create some of those nice graphs to put into exams and things like that. Okay. So I was just kind of curious as to how easy it was to do some of these things on here. I think there was also one for confidence intervals. So I'm just kind of curious here what this does. So I don't know if I want all 100 of those to show up at the same time. I'd probably want to do like one at a time. Like when I do this type of thing with my students, initially we do a couple at a time, so they understand what a red is.
So it creates your
different confidence intervals based on samples of size. In this case, it says 30.
I'm not sure. Screen.
That's a good confidence level type representation, though.
Yeah, that's true. So, all right. Well, I was just kind of curious what was possible and how easy it was to use this, and it seems like it's pretty easy to use, I would say. And you said even just like doing, where would you do like, oh, summary statistics here? No. Like, what if I wanted to get like the mean and standard deviation for any of these columns here?
Summary stats.
So I'm just summary stats. Now let's do this one. Oh, and then you have to, I guess it's going to give you all those, maybe. Yeah, that's pretty nice. Pretty straightforward. All right. Sounds good. Well, if you have any other questions about this, you can definitely send an email to Keisha. Her email address is this correct? I think this is correct. Lanier1@gsu.edu. So if you have any questions, feel free to reach out to her. And I'm going to turn this over now to Tom. So I have to stop sharing. And we'll have Tom share his screen. And while he's getting that set up, I should actually introduce him. So Tom lives in Gilbert, Arizona, where he's taught high school and community college math for the past 25 years. He lives with his wife, Lori, and 2 young sons, Jackson, who's 6, and Camden, who's 3. Due to the young age of his boys, he expects to work in education for another 25 years. Tom loves his position as an educator and has been an AP reader for the past 4 summers. And he's going to be doing a version of his best practice talk called Peanut Butter and Jelly, a Recipe for Success. So take it away, Tom.
All right, thank you. I'm in this top corner. I hope everybody can see me. This isn't a real scientific type of presentation or an activity. It was something that I learned maybe 20 years ago from, I'll just share, an 8th grade reading teacher, though while I presented it myself during the past, say, 15, 20 years, I saw it presented at a community college that I worked at from a professor to other professors as an in-service. And so this is something that works for all ages, for however age your student is. And I find this activity to be most appropriate in a statistics class. I don't know if it's just because it's AP statistics, but we have a very elaborate grading system in terms of what our expectations are from our students in terms of how they write their answers. And when you think of statistics, you know, and how students represent their work, there's usually a story with it, whether it's how they decide to randomly allocate subjects to certain treatments, to creating a simulation, to doing inference work. And so oftentimes I have students who don't always have buy-in in terms of representing their story. They're oftentimes strong mathematicians, but not necessarily ones that are used to writing work beyond just simple calculations. And so getting them to the mode where they have to understand the value of writing complete work and describing their work in order to share their story correctly is sometimes difficult. And so I give this one example here, and I don't know if you can see it with the people, but you know, it says describe a design for an experiment. Be sure to include a description of how you would assign individuals to the specific treatments. And oftentimes I'll have students who will do work like this that, you know, it looks like it started off right, and they have the right ideas. And I think they believe that it's their teacher's job to fill in the gaps, you know, because there's some items missing here about random allocation. There's not any description here in terms of how you're going to do this random assignments, okay? And in the end, you know, there's nothing about comparing your results. You know, did one drug medication outperform the other with respect to gender, or within just one gender, et cetera, okay? And so because I always see gaps within students' work, and I never tell a student, for example, that what they wrote was wrong. I just say, you know, this is a good start, but you need to tell a little bit more about your story in terms of how you're doing your research, because when you leave items out, then you're at the mercy of your reader or the person grading your paper to fill in those gaps themselves. And when they do that, they might not be understanding the same story that you're sharing. And in the end, you lose a little bit of credibility for the work that you did. Okay, so I have this activity, and again, I learned it from an 8th grade reading teacher, but I've seen it again re-represented through college professors for in-service for other college professors, called peanut butter and jelly activity. And here's what I do. I'll pick like a random Friday, and sometimes it's after a moment where I've had a little bit of frustration with student work, where it's just not as complete as we've practiced, and I want a little bit more from them. And I'll ask them, take out a half sheet of paper, and I'll make up a story, and I usually just kind of ad-lib it, but I wrote this one offhand because my little boy was watching Star Wars at the time. And it just says, a good friend Chewbacca decides to visit planet Earth, where he asks for a lunch recipe. Okay, he was told that a peanut butter and jelly sandwich was a popular choice, and that is your job to script for him a set of directions. Okay, and it's something that's very natural to us to make a peanut butter and jelly sandwich, but can you give the directions to someone who has never either seen or created or even knows what one looks like? Okay, and so I tell students specifically on their paper, I don't want your name on it, but I just want you to answer this question. Can you give me a set of directions? And some kids will fill it out. I say kids because I teach anywhere from 15-year-olds to 18-year-olds at the high school I work at. You know, I'll have some that will spend maybe 90 seconds, you know, and they'll turn it in. And I'll have some that'll spend about 10, 15 minutes to work on it. Okay. And again, I never have them put their names on it, because eventually I'm going to present them to the class underneath a document camera. Okay. And before I do that, what I'll do is I'll spend the weekend, I'll read through every one, and I'll pick some that I think are very vague, and I'll pick a couple that are very complete, you know, that actually give a good representation. And I always start with one of the more vague ones. And before I put it up on the board, I'll have with me in my class jar of peanut butter. Okay. I have the jelly, I have a loaf of bread, and I've got a knife. Okay. And what I do is I reenact their directions as they share them on their paper in front of the class, and I let the students read what someone had written in terms of their set of directions. Okay, so here's an example of the first one. And again, I have all my supplies. It's witnessed in front of the students, and I just go. And the first one says, obtain 2 slices of bread from a loaf of bread. The slices should be originally together, so they can line up exactly. Okay, so that direction is kind of vague, so I'll just take the bread and I'll grab 2 slices that are next to each other. Okay, and I have my 2 slices right here. It says separate the slices so they touch each other face up. Okay, so I'll just put this here and I'll try to tilt my camera a little bit so you can see it. Okay. Third item says spread a light amount of peanut butter evenly on both sides. Okay, so that is open to my interpretation. I'm going to take the peanut butter and it says to spread it on both sides. Now, I don't know what both sides means, okay, but it could mean this side right here, okay, and it could mean this side here, okay. Oh man, yeah, it said lightly. I try to do as light as I can, and then I'll do it maybe on this side right here, and it's kind of, again, open to my interpretation, okay. Fourth one says spread a medium portion of raspberry jelly on one slice. Okay, so I will actually get raspberry jelly if that's what they have. And again, I always look at it a couple days ahead of time, and so I'll grab the jelly and rub it on one slice. Okay, place back together so that each slice is lined up perfectly. Okay, and again, that's up to my interpretation, and this is the sandwich that I get. Okay, and so students will respond. Of course, they'll think you're crazy for doing it, but they begin to get the idea that as you show people what the directions are from some student, that what we feel is complete is not always complete to your reader, especially for someone who has never participated in such an activity before in the past. Okay, so that is usually my most vague representation. Okay, and that's the one I'll do first, and then I'll find one that's a little bit more complete. Okay, and so I'll put this one off to the side and we'll start over. And it says, get out jars of peanut butter and jelly and 2 pieces of bread plus a knife. Okay, so cool, we have a knife here. And I don't mean to backtrack, but when we go back to this, one thing I forgot to share, we'll share what was missing, what gaps were there. You know, what are some things that would have made this a little bit more complete, so I wouldn't have got the sandwich that you really don't want to see. Okay, and so we would say, yeah, you use your hands because there was nothing about a knife demonstrated or represented. We'll talk about what a side means. Does side mean a face? Does it mean the outside? Does it mean the backside? That has a lot of different representations. Okay, so this one's a little bit better because it said use a knife. Okay, so get out get out a jar of peanut butter and jelly and 2 pieces of bread and a knife. Okay, so I'll get out 2 more pieces of bread just like before. Okay, it says use a knife to spread on 1 piece of bread. Okay, so I'll do that. Okay, I'm going to get my knife. Okay, and it says use it to spread on 1 piece of bread. So I'm going to take my knife and I'm going to use this right here, and I'm going to spread on the bread. Okay, so it's good that they had us talk about using a knife, but again, there's more detail that could have made this a little bit better. Okay, clean off the knife. Okay, so I'm going to clean off the knife. It's a little messy, so I'm just going to clean it off. Okay, and make sure that it is ready for use for when I do my next piece. Okay, it says apply jelly to the other piece. It doesn't say anything with a knife, so I'll use it the way that I feel is most comfortable. Again, I'm Chewbacca, and so I don't have a conscience about doing stuff like this. And then smush the 2 together with the peanut butter and jellies. Okay, so I'll smush them together, and there's my sandwich. Okay, so that one is a little bit more complete. And we'll talk about how our directions are a little bit more appropriate for this one versus the previous. Okay, so yeah, we'll talk about, yeah, we needed to use a knife, but what was the weakness in that? Is that, yes, we should probably talk about using the blade end, okay, as opposed to the butt end of your knife. Okay, talking about smashing the bread together, I kind of know what they mean in context, but really, is that the detail that we want to give? Okay, and in time, I'll do maybe 1 or 2 more, and by the time I do the last one, okay, the last one will be one that's pretty close to perfect. Okay, and I could probably go through and find something that isn't exactly right with pretty much anyone that is handed in, but in the end, I want to give one that's perfect and have us go through it step by step, right, and get the approval of the class before we move on to the next step, just to make sure that we are right. Okay, and in the end, once we find one that's perfectly good, and we're able to make a sandwich that looks edible and one that you're used to seeing, then you kind of get like a small applause from the class, and they're like, oh, who's the one who wrote that one? And we sometimes identify that person. Okay, but it's after this activity where sometimes students will do my work just for the sake of doing it so they can get their points. And when I say work, it means, writing out the important details again of simulations or experimental designs, or your inference testing where you need to write your null and alternative hypothesis, what you're thinking about ahead of time, your conditions to make sure that your test is appropriate, okay? Showing you all your proper mathematics with whatever test you choose to use, and then writing a good sentence. So many times students will say, hey, do I have to say reject or not reject the null? Can I just write the other pieces to my answer, whether, just a sentence? And it's like, no, you have to include that, They'll say, hey, when we're doing, random assignments and we're using 2-digit numbers, do I have to say 2-digit numbers, or can I just say, hey, we're picking numbers, from a random digit table? It's like, no, you need to be specific. Do I have to say compare results? Yes. You have to share your total story, especially when you're doing research, because every part of it is important to show that the truths that you come with are valid. Okay. And usually after this activity, I get some more buy-in. I'll have students who maybe were a little bit more lackadaisical at first in terms of writing such responses will look at this and say, all right, I kind of get it. I understand why I need to include such details so that in the end, my story is complete. Okay. So I don't know if there's too much more than that. Again, I just said right there that there's always one student that will have a pretty good recipe. I think it's always good to share one moment, okay, where a student does a good job, and lets people know that people actually do this. People actually give good representations for their practice in terms of how they make their design. So, okay, that's more or less my contact information. I'll share this. I'm so confident about the value in this that I oftentimes, in terms of this this activity, that I'll do this sometimes for my my evaluations. So if I'm evaluated by my administrator at school, I'll do this as an activity, and I usually get a fairly good response from my administration, just because it is practical, and maybe more so that I see in statistics, but it really could be for any math class. It could be for any class in general. But when I started teaching this class, teaching AP statistics, and I saw all the detail in terms of what makes an answer complete, and you can see that just with our rubrics for our AP exams, having this type of practice, or demonstration, kind of lets students know the real reason why we have it all. Because if we don't include all the parts to our story, again, we're at the mercy of our reader. And let's just be honest, people are very critical when it comes to evaluating other people's work, and they're looking for something wrong or something incomplete in your work. And if you're doing important research, you got to make sure everything's there. And if you have that and it's substantiated, then there's a lot of trust in terms of what you did. So, and that's all I have.
Well, thank you very much. And I hope you're able to get your shirt clean later on.
What I'll say is I've done this so much where I know the peanut butter will come out. And you have to remember, if you do this, you'll have to bring a spare shirt. And if you teach it multiple times in a school day, you'll have to. Yeah, so that's, yeah, it'll come out, I promise you. I'll say this, the hardest part about this activity is having the courage to do it, okay? But once you do it once, and you see the responses of your students, and you see how well they perform on future items, that you give to the, in terms of representing complete work, you'll understand the value. And for some, it looks a little silly, and it is, and you're gonna get a lot of laughter from your students and some screams, and but in the end, if you can just get past that moment, even though it's a kind of a different dynamic for your class, I think the effect of it is very profound. So,
do students in some of your classes say, reference the peanut butter and jelly, like, you're to another student, like saying that you don't have the full peanut butter and jelly recipe or something like that? Do they?
Oh. You know what? I haven't talked about it, but I don't know if I've heard it in that terms, but I often reference that, if I'm teaching, say I teach this around time when we're going over a random assignment or maybe some simulations, when we get to, say, inference, and I know there's a lot of a lot of unique type of work to represent a full answer, I'll say, hey, remember the peanut butter and jelly activity where I had, you know, a lot of detail to represent a complete answer? This is one of those moments where I need you to share that with me in this time, you know, because I'm going to need 5 parts, and I can't have you shortcut any of these, because all of them are super valuable to making your study or your evaluation look correct. Okay, so
Great. Well, we have a couple people in the chat just saying thank you for presenting. So I just want to let you know that thanks to both of you. I really appreciate you taking your time tonight to share. And if you have any questions for either Keisha or Tom, feel free to reach out to them. And if you are like, oh gosh, I missed the contact information that was up there, you can always find this video on our YouTube channel, Teaching Statistics Across Any Setting. It'll probably be posted at some point tomorrow, and you can always go back there and check it out. You know, and if you need a laugh, definitely check out the part where Tom's wiping the peanut butter on his shirt. So, all right. Well, thank you, everyone. Have a wonderful evening. And I'm going to stop the recording now.
thanks for hosting.